Hello, welcome to lecture 38. And during this lecture, we are gonna continue in week 12 and entering week 13. As you know, the week 14 would be the last week of the semester. So by the time that you are taking this course, it's safe to say you have only 2 weeks left for this spring semester. Once again, I'm very sorry that we didn't have opportunity to meet each other in the classroom. It would have been a much more fun, but the safety and health is the most important thing. So believe me, we are gonna have some kind of party or something in summer if the coronavirus got safe. So until that time, we are gonna continue the second last week of the law in economics. Wow, as I have said, that the topic of tort law would be very heavily involved with calculations. Well, even though I said that, you might have not expected that the last topic would be so much different from the first two topics, in the way that the first two topics, the property law and the contract law, are mostly verbal, but this is by calculation. But this calculation, we just want to be really accurate and really meticulous about our analysis. However, in general, the spirit is same. Okay, summing up what we have done, we are considering strict liability and negligence, and when the precaution level is required only for the injurer or one party, then both are uh, equally efficient, in the sense that both strict liability and negligence rule enforce the injurer to set the precaution level same as the socially optimal level. However, when the precaution became bilateral, which means it's not only the injurer but also the victim should be careful in order to reduce the probability of accident, then the strict liability cannot make it efficient. On the other hand, negligence can. The simple intuition is that under strict liability, every liability or responsibility is on the injurer. So the victim would be totally careless, and knowing that the injurer would be overly careful. So it never would be a efficient one. On the other hand, in negligence, we tell, as I said, it can be victim too, but we tell the injurer, for example, as long as you put your precaution level at certain point, which would be the socially optimal level, even though there is an accident, you are not going to be responsible. So the injurer would exactly set its precaution level at the socially optimal, given that the victim would calculate what should my precaution level, conditional that the injurer's precaution level is the same as the socially optimal level. After calculation, the victim would find out, oh, I should set my precaution level same as the socially optimal. So the negligence rule achieve both precaution level same as the socially optimal level. Okay, that is what we have done in lecture 37. In lecture 38, we have a new assumption, which is activity level. What is activity level? Activity level is a certain should satisfy, this activity should satisfy two conditions. it should have certain effect on the probability of accident. So the probability P of accident is not only the function of xi and xv, but also A. Another important feature of this A activity level is cannot be regulated by law. If you think about the driving a car, if you are speeding up, the police or CCTV measure your speed, and if you are speeding up too much, you have to pay a penalty. Traffic signal, if you violate traffic signal, then you will be caught and you will be punished. If seatbelt is not on, you would be punished too. All these speeding, traffic signal, violation of traffic signal, and not fastening your seatbelt, they contribute and increase the probability of accident. But there are other things which also increase the probability of accident. That is, how many hours do you drive? How many hours did you sleep last night? Okay, you are a very good driver, and you drive like 10 hours a day, every day. Tell me, whatever driver you may be, you would end up getting an accident ultimately, because if you don't drive, if you're a horrible driver, but if you never drive, no accident. So these driving hours definitely affect on the probability of accident. I'm talking about this too much, but think about the corona situation. Because of corona situation, people don't come out, they do not drive, so car accident has reduced enormously during this period, because you cannot have an accident when you do not drive. Sleeping hours. If you have a very small hours of sleep, very little sleep at night, your chance of getting accident is very high. But have you ever caught by the policeman because you drive too much, or because you didn't sleep very well last night? No. Somehow the police cannot catch you. Why? Think about that. If the law says nobody can drive more than 8 hours per day, think about a truck driver or taxi driver who has to make a living by driving a long time. Maybe not every day, but sometimes they have to do that. And then, if the government block it, they would say, come on, who would provide food for my family? When you prevent me from driving more than 8 hours, my family would starve to death. So some political reason, it's very hard for the government to regulate the driving hours. Sleeping hours, come on, some people say that, I have no problem. I sleep just 2 hours a day and I never doze off. I'm not, that's enough for me. And how dare the government say that 2 hours is not enough? Not to mention 6 hours, that's not enough. You should sleep at least 7 hours a day in order to drive. My God, how can you measure that, first of all? And if you can measure that, how can you possibly preventing people from driving when they sleep like 5 hours? So politically or technically, those things are very difficult. So cannot be regulated by law, even though driving hours and sleeping hours has a great influence on the probability of accident. Here, one thing I kind of apologize or clarify is that the A here is not activity level. It's the precaution level on activity. So when the activity increase, A would decrease, because the more activity means you are less careful. Okay, it's like speeding. When your speed goes up, the XI precaution level goes down. On the other hand, if your activity goes down, A, the precaution on activity goes up. So A is not activity, but it denotes the precaution on activity. Okay, Now, time for calculation. So let's calculate the social optimal level when we include the activity level. Oh, activity level. I'm sorry, it's not R, it's L. Activity level considered. Assume that now A, the damage is 10 powered by 12 instead of 10 powered by 6, Okay, I will explain, but we need this big number to get a nice result. And the Wi, Wv, and now Wa are all equal to 1. And the probability include not only 1 plus xi, 1 plus xv, but 1 plus a, because the precaution on activity it increase, the probability of accident decrease. So we have to find out, I have to L here, unlike here, optimal level of precautions xi and xv and activity a. So let's find that out. By this time, I hope you are accustomed to calculating things. So with all these numbers, you compose a social cost, which should be x w1 wixi wv xv plus waa plus p multiply a, and you differentiate this social cost with xi and xv and a and puts all three of them 0. By doing that, I hope you can correctly find out xi should be equal to xv should be equal to a. So they are all same numbers. So when you put that back to first order condition, you should do that. I'm not doing that for you anymore. But if you do that, the same way I did in previous lecture, you will find out 1 plus xi powered by 4 would be equal to 10 powered by 12, which means xi should be equal to, you cancel 4 and 12, 12 should be 10 powered by 3, so 999. But then we know that xv, a are same as xi, so all xi, xv, a, the optimal, all three of them should be 999 in our numerical example. Okay, don't be so gloomy or something. Calculation can be fun. And this is not something you need a lot of high-level mathematics. You just do basic differentiation and adding up and things like that. Then you will get the number. So that is social optimal. Now, we know that because there is injurer and victim both should be careful. We already know that strict liability is hopeless to get the efficient result. On the other hand, the negligence rule was good. So let's try the negligence, but negligence on the injurer. The injurer has this rule: if injurer's xi is less than xi star, which means he is not careful enough, his cost of injury would be wixi, small number, waa, that is cost of being careful, being precautious, multiply, a is here, p multiply a. So when there's an accident, because injurer was careless, he should be responsible. On the other hand, if he was careful enough, xi is bigger than y equal to xi star, he is not, the injurer is not responsible for a anymore. Therefore, his cost function is wixi plus waa. Okay, this may be small and vague, but my TA posted all this PPT in my YSEC, so you can find out the PPT file over there, which became very big, 130 something pages, and then you can look at it carefully. But I think even though my handwriting is not perfect, Still, it is okay on the screen. But anyway, once again, you can print it down from the PPT I posted, my TA posted on YSEC. If you cannot find out, ask my TA or ask me. Okay. In this case, what would the injurer do? This is very important point. Because the precaution level xi, if that is smaller than xi star, he should be responsible for this damage from the accident, every amount of it. So he doesn't want that. So he would choose his xi would be bigger than or equal to xi star 999. So xi would be same as 999, so that the injurer would not be responsible if there is any accident. But then you remember the activity level is something the government cannot force onto the injurer, so they cannot regulate A. What would happen? The bigger the A, the cost would increase. If A is 0, this cost would be 0. So in order to minimize, because he already chose xi star, his cost function would be the second line. And then in the second line, how can you minimize it? Set A to 0, then this part would become 0. So under negligence rule, the injurer would choose xi at the optimal level 999, but activity level, the precaution on activity, as 0. So he's not going to be precautious at all, careful at all, as long as the activity level is concerned. He just party on and very sleepy, still driving. He drove like 10 hours, 12 hours a day. He keep doing that. In this case, what would happen? Because xi is 999 and a equals 0, from victim's point of view, victim's cost function would be xv. Of course, wv equals 0, that's why it's only xv. 1 multiply xv plus this. Why? 1 plus xi would be 10 power by 3. I'm sorry. It's 3. Yep. Calculation error. Let me see. What was the optimal level? 999. 10 power by 3. It should be 10 power by 3. Sorry on that. And a would be 0. So let's quickly recalculate. 10 power by 3. Then this will be 10 power by 9, right? Yeah, I made some mistake here, I think. Okay, let's continue. 10 power by, because 10 power by 3, this should be 10 power by 9 instead of 10 power by 8. So xv would be same as, a little bit different, root 2, something like that. Yeah, sorry on this. So it's not 999, but maybe a little bit half of that. Okay, help your old teacher, and why don't you calculate by yourself? So basically it's gonna be 10 power 9, so it's like root 10 multiply root 3. So something a little bit less than, something bigger than 9999. Okay, because it's 10 power by 9 instead of 10 power by 8. So the number should be bigger. Okay, 999 multiply root something. Okay, you are smart enough, you calculate. What is important is, here XV is much bigger than the optimal level 999. Okay, where is it? Here, XV should be 999 at optimal, but here I miscalculated, but XV is actually much bigger than 999, so bigger than the optimal level 999. It's something bigger than 9099. So obviously bigger than that. Inefficient. Once again, I apologize that there's some calculation error, it seems, but then you can calculate. It's enough if you can see XV is something bigger than even 9,999 and definitely much bigger than 999, which is socially optimal. So even though among the three things, Xi is optimal, but A is too little because it's 0, XV is much, much bigger than the optimal XV star. So it's inefficient. Okay. How can we solve this? Now, negligence rule does not guarantee efficiency if there's activity level. Yeah, but there's another negligence rule we can apply, that is, what if instead of negligence, okay, where is it? Negligence on injurer, the injurer's precaution level should be Xi star, should be the standard criterion, and it doesn't work. So let's make the victim's optimal precaution level as criterion. So if victim is not careful enough, XV is less than or equal to XV star, so XV is less than 999, this would be the victim's cost, because you are not careful enough, so if there's an accident, you are totally responsible. But if victim is careful enough, which means XV is bigger than or equal to XV star, A is not victim's responsibility anymore, it's the injurer's. So only the being careful, the cost of being careful, it would be the cost of the victim. So obviously, XV would be, the victim would set its precaution level XV at the optimal XV star 999. Given that, now, because the victim sets the precaution level at the optimal, if there is any accident, that would be the cost of the injurer. So the injurer's cost function would be WIXI, WAA, activity level, and P multiply A. Here, XV would be XV star 999. Once you put it here, it's going to be 1 plus XV, XI, and 1 plus XV would be 10 power by 3, and 1 plus A. That would be the new probability of accident when the victim sets its precaution level exactly same as the socially optimal level. And I ask you to do the first order condition, partial differentiation yourself, differentiating CI with XI, CI differentiating by A, and set them 0. Once again, you will find out XI should be same as A in this case, and 1 plus XI power by 3 would be 10 power by 9. So, XI would be 999, A, same as XI, 999. Wow, efficient result, because XV is 999, I and A are 999. If you go 2 pages back, that is what guarantees a social optimal level of precaution. And as a result, social efficiency has been achieved. What's the difference? Here we call the injurer I, who has, here the activity level is the activity level of injurer, not the victim. And we make the injurer who has activity level as residual bearer. Residual bearer. What is the definition of residual bearer? The person who takes the responsibility when nobody was negligent. So when xv is bigger than xv star, xi is bigger than xi star, so we cannot blame anybody because both victim and injurer were careful. But still, when there's an accident, somebody should pay. It's like there's a car accident. Tom's car hit Bill, then if Tom is and both Tom and Bill were careful, but still there was an accident. If Tom's responsible, Tom pays Bill's hospital medical fee. If Tom is not responsible, Bill is paying his own fee. So that should be decided. If the court say, okay, Tom, you are careful enough, you're a careful driver. Bill, you are careful pedestrian, but accident happened. So who pays? Tom, you should pay because the court say you are the residual bearer. Nobody did anything wrong, but still someone pay, you are. So if we make the injurer who controls A as residual bearer, what would happen? The government cannot control A, but the residual bearer think if there's an accident, it's my responsibility and I can control A as well as XI. So I will do my best by choosing proper XI and A and minimize my individual cost. So when the government does not control Tom, what should it do? Make Tom the residual bearer. So even though government cannot control Tom's exact precaution level, Tom should realize, oh, even though the government cannot tell me you should not drive so many hours, you should take some good sleep before you drive. But if I don't do that and there's an accident, I'll be in charge. I'll be responsible for every damages. So even though the government does not tell me to do, I will sleep a lot and I will reduce my time of driving to the optimal level. Okay? So the key point is making the person who has the activity level which cannot be directly regulated as the residual bearer, then the social efficiency in total law would be able to be achieved. Okay, this is the end of lecture 38. And as I told you, we are already dipping into the week 13, which means we have only 1.5 weeks left until the end. Less than 2 weeks, let me put it this, less than 2 weeks left until the end of the spring semester. Congratulations in advance.